When we hear the word surds, we tend to think of square roots, although surds can also include cube roots, fourth roots, fifth roots, etc. However, for core 1, we only deal with surds that are square roots. Let's define what we mean when we say surd, because it isn't every square root. A surd must be a root which doesn't have an integer value, and some square roots are whole numbers, so we wouldn't classify these as surds. Any square root that isn't a whole number is in fact an irrational number. This just means that the decimal expansion of the answer would be infinite and have no distinguishable pattern. So let's look at simplifying surds. We can split any square root into two separate square roots, just like we split numbers into factors. Often this isn't helpful, but sometimes we can bring out a square number root as a factor. This is effectively simplifying the surd. Although at first it may not seem simpler, you'll soon see that it does sometimes lead to some nice cancellations at the end that would otherwise be difficult to see. Multiplying brackets is a simple process, just like when we multiply outer bracket brackets. The trick is when multiplying two numbers together, first multiply the numbers and then multiply the surds. Never multiply a number by the surd inside, i.e. 2 times by the square root of 3 would not be the square root of 6. Here we come on to the main topic for surds, which is rationalising the denominator. These questions are an exam favourite, so remembering them is key. To rationalise the denominator, this just means to multiply by what we call a conjugate, just a fancy way of saying change the sign in the middle. So in this example, we multiply by root 5 plus 2 over root 5 plus 2. The reason we're allowed to do this is because we are effectively multiplying by 1, so we're not actually changing the expression itself. The method behind these questions is straightforward. Just be careful when multiplying out, as it's easy to make a mistake, and don't forget to simplify down at the end if possible.